One card is drawn from a standard deck of 52 cards. What is the probability that it is a red card or a face card? So here's the clue. This is an OR problem, and this is the formula. Probability of A or B is probability of A plus probability of B minus probability of both. So that would be the probability of a red card plus the probability of a face card. So here are the red cards. There are 26 red cards out of 52. Plus, here are the face cards, Jack, Queen, and King. So there are 3, 6, 9, 12 out of 52. And in this particular case, you can clearly see that there is an overlap, so minus probability of red and face card. So there are 1, 2, 3, 4, 5, 6 out of 52. A card is drawn. Again, one card is drawn, and here is the hint. It's an OR problem. So probability of ace plus. So there are 4 aces out of 52 plus the probability of face card, and there are 3, 6, 9, 12 out of 52. And since there's no overlap, it's just probability of A plus probability of B. So mutually exclusive means there is no overlap. So this one here is the mutually exclusive event. And of course, you do need to simplify it. So that would be 38 minus 6, 32 out of 52. And this is going to be 16 out of 52. And reduce, divide by 4 is 4. Divide by 4 is 13. Divide by 4 is 8. Divide by 4 is 13. If you flip a quarter, a dime, a nickel, and a penny, what is the probability that you get exactly 2 heads? Well, when you do this, you are going to have an enormous sample space. And this one here is just flipping 2 coins. 1, 2, 3, 4, 4 coins. So the first coin, second, third, and fourth. Exactly 2 heads would be this one right here. And this one right here, 2 H's, 2 H's, 2 H's, 2 H's, and 2 H's. So one way to do it would be to create an enormous sample space and then see how many 2 H's you have, which is 6 out of 16. And that is a really, really cumbersome task. So this is what binomial probability is all about. So binomial probability is when you have independent events. So here, when you toss these coins, the event 1 is not going to affect the outcome of event number 2 or 3 or 4. You can flip the coins as many times as you want, and each time that probability for the other ones will not change. Independent events and the order doesn't matter. When that happens, then you can use the binomial probability. Independent events, order not matter. And the formula goes like this. NCR, and then probability of success, probability of P to the R, 1 minus P to the N minus R. So we're going to see how many chances were you given. You're flipping 4 coins, so out of those 4 tosses, you want 2 of them to be heads. The probability of heads is 1/2, and you want to have that happen twice, and not H is going to happen 2 times for a total of 4. And for C2 is 4 factorial over 4 minus 2 factorial times 2 factorial. 1/2 to the second power is 1/4. 1/2 to the second power is 1/4. And this is 4 times 3 times 2 factorial, 2 factorial, and 2 factorial times 1 over 4 times 1 over 4. So 4 and 4 is gone. So the final answer is 3 out of 8, which is what we had before. So NCR, P to the K, 1 minus P to the N minus K. That's the formula. And so we did that already. And let's look at this. A coin is weighted, so the probability of H now is 0.6. What is the probability of getting exactly 2 out of 5 tosses? So you have 5 experiments, 5 chances. Out of those 5 coins, you want 2 of them to be H. The probability of heads is 0.6, and that's going to happen 2 times, and not H, the tail, is going to happen 3 times because you toss it 5 times. So that means 2H and 3T for a total of 5. A fair die is rolled 10 times, independent events. Exactly 2 sixes out of 10 ordered is a no. So that's how you know it is binomial probability. So you're given 10 chances. Out of that 10 roll, you want 2 of them to be 6. The probability of getting a 6 is 1 out of 6. That's going to happen 2 times. Not a 6 is 1 minus 1 6. And that's going to happen 8 times for a total of 10. At most 1 6. So if you roll it 10 times and you want to at most 1 6s, you can either get no 6, 1 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6. Okay, so you can get no 6s at all, or 1 6, or 2 6, or 3, or 4, or 5, or 6, or 7, or 8, or 9, or all 10 of them will be 6s. At most 1 6 will be these two right here. So we're going to have no 6 out of the 10 roll. You want none of them to be 6. The probability of getting a 6 is 1 6. That's going to happen 0 times. And 1 minus 1 6 will happen 10 times. Or out of the 10 roll, you want one of them to be a 6. The probability of getting a 6 is 1 6 to the 1 power. 1 minus 1 6 is going to be to the 9 power. And that's the answer right there. And this is the answer for this 0.29 for the first one. To get at least 2 6s means, let me just do this one more time. You roll it 10 times. So either no 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 6s. So you can do for the probability of getting a 2, 6, a 3, a 4, 5, 6, 7, 8, 9, 10. You're going to add this all up. Or we know that the total probability is always 1. And if we subtract those two probabilities, we're going to end up with the probability of getting 2, 6, 3, 4, 5, 6, 7, 8, 9, 10. So 1 minus the probability of no 6 minus probability of 1, 6. So 1 minus no 6 will be out of the 10. You're going to get no 6. Probability of getting a 6 is 1 6 to the 0. 1 minus 1 6 will happen 10 times. And you're going to subtract this one right here out of the 10. You want one of them to be a 6. The probability of getting a 6 is 1 6. That will happen 1 time. 1 minus 1 6 is going to happen 9 times. And that's the probability right there. Patients infected with a virus has a 40% chance of surviving. There are 10 patients in the hospital who have acquired this virus. Find the probability of 7 or more of the patients survive. These are independent events, and order doesn't matter because 7 out of 10, and it doesn't matter what order it is in. So binomial probability. So if there are 10 patients, you want 7 or more means you want 7 or 8 or 9 or 10. And that will be 0, 1, 2, 3, 4, 5, 6. The total is 1. So I can do 1 minus all of that to get 7, 8, 9, 10. But I think it's a lot faster to just do 7, 8, 9, 10 added together. There's a lot more work to do this one right here. You have to do 1, 2, 3, 4, 5, 6, 7 times versus 4 times here. So 7 of them out of the 10, you want 7 of them to survive. Probability of surviving is 0.4 to the 7th power, 1 minus 0.4 to the 3rd power, plus 10 C8, 0.4 to the 8th, 1 minus 0.4 to the 2nd power, plus 10 C9, 0.4 to the 9th, 1 minus 0.4 to the 1st power, plus 10 C10, 0.4 to the 10th, 1 minus 0.4 to the 0 power. And that is, probability is approximately 0.05476, 1 in 20 chances, or 5% chance that 7 or more patients will recover. So if you have a fair die and observing the number of dots, probability of getting a 1 is 1/6, a 2 is 1/6, 3 is 1/6, 4 is 1/6, 5 is 1/6, and 6 is 1/6. So the histogram is just going to be like this, and this is called a uniform distribution. Okay, so you have 3 red and 5 blue. Independent means it's with replacement. Dependent means without replacement. If the order matters, all you have to do is just multiply. That's all you need to remember. It says first, second, third. So the first time you pick, there are 3 red marble out of 8 total. You put the marble back. So the second time you pick, there would still be 3 red out of 8 marbles. The third time you pick, you want a blue, and there will be 5 blue out of 8. Red, red, blue again, except this time it's without replacement. So the first time there's 3 red out of 8. Now there's 1 less red because it's not replaced, so there's 2 red out of 7. And in the last pick there are 5 blue still, but now there are only 6 marbles left. Order matters, multiply. You get 2 red marbles and 1 non-red marble, and it's with replacement. So with replacement means it's independent, and order doesn't matter. That's what we learned today, so that's how we know that this is the binomial probability. So you are picking 3 marbles, 2 red and 1 non. So out of those 3 picked, you want 2 of them to be red. The probability of red is 3 out of 8. That's going to happen 2 times. And not red is 1 minus 3, 8 will happen 1 time. And this one here is you get 2 red and 1 blue. And it's without replacement. So order no. And it is dependent event. So this is the only one where you have to use that magician's formula. So if you want to get 2 red, then what you will do is you're going to have in your invisible bag, you're going to have 2 piles. This is the red pile and this is the blue pile. And there are 3 red in there and there are 5 blue. So if you want to get 2 red, then you're going to pick out of this bag right here. So out of the 3 red, you're going to pick 2 of them. And then out of this pile here, you're going to pick 1 of them. But what you're telling your audience is you're going to pick the 3 marbles out of the whole pile of 8. So this is the trick, and this is what you're telling your audience. 3 red, 5 blue. This time you're picking 2 marbles. Red, then blue. Multiplication. Whenever it says then, that means you multiply because order matters. So red will be 3 red out of 8. Then blue, so 5 out of 8 because you replace it. Red, 3 out of 8. Then multiply. Blue, 5 blue out of 7 marbles total. Order doesn't matter, you just want to get 1 red, and it is with replacement, so this is the binomial probability. Okay, you're picking 2 marbles. Out of those 2 picked, you want one of them to be red. The probability of red is 3 out of 8. That's going to happen 1 times. 1 minus 3 out of 8 will happen 1 time. You want to get just 1 red, so that means from this red pile, you're going to pick 1. Out of the blue pile, you're going to pick 1. So 3 red, pick 1. 5 blue, pick 1. 8 total, pick 2. Order doesn't matter. 3 cards are drawn, probability of a 2, then 3, then 4. And this is with replacement. So there are 4 2s out of 52. There are 4 3s out of 52. There are 4 4s out of 52 because you replace it. You get a 2, 4 out of 52. A 3, 4 out of 51 because you did not replace the card that you picked. And then 4 4s out of 50. Then means order matters. Order matters means you multiply. 2 kings with replacement. So this is with replacement is your clue that it will be a binomial because the order doesn't matter. So we have 3 picked. Out of those 3 picked, you want 2 of them to be king. Probability of king, there are 4 king out of 52. You want to have that to happen 2 times. And 1 minus 4 out of 52 will happen 1 time. 2 kings without replacement. So you're going to have a pile of king, a pile of non-king. Out of this pile of 4 kings, you're going to pick 2. Out of the 48 of non-king, you're going to pick 3 cards are picked. So out of the 48 non-king, you're going to pick 1. And you're telling your audience that out of the pile of 52, you'll be picking 3. 8 cards are drawn. Find the probability of drawing 1 spade. Order doesn't matter. So with replacement will be binomial. 8C1. Probability of a spade. There are 13 spades out of 52 will happen 1 time. 1 minus 13 out of 52 will happen 7 times. Without replacement, so you're going to have a pile of spade and a pile of non-spade. Out of this pile of 13, you're going to pick 1. Out of the pile of 39, you're going to pick 7. Out of the pile of 52, you're going to pick 8 because 8 cards are drawn. So 1 spade, 7 non-spade. 5 red, 4 green, 3 marbles are drawn. Then it's multiply. So 5 red out of 9. Then green multiply by 4 green out of 9. Then green 4 out of 9. Red 5 out of 9. Then green 4 out of 8. Then green 3 green out of 7. 2 green with replacement. That's the binomial. You are given 3 chances to get 2 greens. Out of those 3 picks, you want 2 of them to be green. Probability of green is 4 out of 9. That happens 2 times, 2 greens. 1 minus 4, 9 will happen 1 time. 2 greens without replacement. So here's the pile of green and here's the pile of this other pile of red, non-green. So out of this pile of 4 green, you want to pick 2 of them. Out of this pile of 5 red, you're going to pick 1 of them. And out of the pile of 9, you're picking 3 of them.